Aloha and welcome back to our afternoon sessions. My name is Jenna Stone and I am the moderator for this session titled Construction BMPs for Post-Construction BMPs. Please use the Q&A feature during the presentation to ask any questions you may have. At the end of the presentation, we will have a few minutes for the speaker to answer your questions. Without further ado, I'd like to introduce our speaker, Jon Lowry. Jon Lowry is a water resources engineer at Enviro Services and Training Center, LLC. Since 2013, Jon has provided support to the State of Hawaii Department of Transportation, Highways Division, Oahu District in implementing their stormwater management program plan, including the post-construction BMPs program. Please help me in welcoming Jon Lowry. Good afternoon, Jon.
Hi, thanks, Jenna. Okay, I'm gonna share my screen. And
Don't see it yet.
I'm thinking it. There we go.
Awesome.
And one more step. My PowerPoint up. Okay, can you see my presentation?
Yes, looks good.
Great. Okay, everybody, thank you for joining this session today. As Jenna mentioned, this presentation is mostly about the post-construction BMPs program. So you've probably spent most of your day and you've probably come here today to learn about construction BMPs, but I'm here to fill you in a little bit about one of the other programs, post-construction BMPs, giving you a little background on what is a post-construction BMP compared to a construction BMP, and why it's important and relevant to during the construction process to also implement BMPs and also for long-term maintenance. So brief overview here. As you can see, these are the main program elements of the stormwater management program. And you can see that construction site runoff control is just one of the elements, and post-construction stormwater management and new development and redevelopment is another program. And I'm going to discuss a little bit how those are linked. And as you can see, there's also a lot of other pollution prevention, good housekeeping, industrial, commercial, municipal, industrial, monitoring, total maximum day load, and reporting. So just to give you a little overview that there's more than, there's several programs that we're managing for HDOT. Oh. Okay, so first of all, what is a post-construction BMP? Often you'll hear the term post-construction, sometimes you'll hear the term permanent. The terms are used interchangeably a lot of the time, but the most proper term is post-construction BMP, and as opposed to a construction BMP that's installed for the purpose of controlling sediment and stormwater runoff during the construction process, a permanent BMP is left in place to control and minimize discharge of pollutants from activities long after the project is constructed. And one of the BMPs that we try to implement most often is called low impact development. And low impact development is a permanent BMP that attempts to mimic pre-development site hydrology by using site design techniques that store, infiltrate, evaporate, and detain runoff. And if you can hang on just a second, I'm going to turn on a fan because I had to close my window because a wood chipper started up next door, and now I'm getting hot. Hang on a second.
No worries. The struggles of working at home.
Okay, I apologize for that. Interesting stuff we're dealing with in the days of COVID. So what triggers the need? Why do we even put in post-construction BMPs? there's a unified criteria that is included in the permanent BMP design manual. And basically all non-exempt projects that are new and redevelopment that disturb an acre or more have to be reviewed for required stormwater controls. And then also smaller projects that have like retail and gasoline outlets, car washes, auto repair shops, and restaurants with 10,000 square foot of area, parking lots. These are all the types of projects that require review and for permanent stormwater controls. And then the way you determine which sorts of triggers, whether your project is triggered and what sort of requirements you'll have for your post-construction BMP is by referencing DOT Highway's Stormwater Permanent Best Management Practices Manual. And this manual is available on the Stormwater Hawaii website. So in addition to a project having a trigger like based on size or the type of project, there are actually other programs within the stormwater management program that require permanent BMPs. One is the action plan for retrofitting structural BMPs. We have total maximum daily load implementation and monitoring plans. So throughout the island, there's different watersheds, and where DOT roadways pass through watersheds that have total maximum daily loads, they're allocated waste load allocations. And in order to meet those waste load allocations, DOT Highways often has to construct permanent BMPs to reduce nutrients to meet the maximum waste loads. There's also the erosion control BMP program. You may have listened to Jason and Mark's presentation earlier this morning, where they went into more detail about that program. Action plan to address erosional outfalls. So DOT has thousands of outfalls on the island, and they do have a plan to repair outfalls that are causing erosion and sediment runoff out of the stormwater system. Then we also have trash reduction plan. So once all these are complete, these PBMPs are tracked, inspected, and maintained under the post-construction program. So a message for contractors, designers, proper construction and installation techniques are critical for the optimal long-term function of permanent BMPs. So we always want your BMPs to be installed properly, even construction BMPs, but construction BMPs are only meant for the life of the construction activity, so maybe not quite as critical. These permanent BMPs remain in place permanently. So it's important that they get constructed properly and that they're protected during construction as well. Structural BMP treatment devices, we also typically include a 9 to 12 month maintenance period, and that's so that the contractor that actually installed the device is going to be responsible for maintaining that device. So it's important for you to know what the maintenance requirements are. And it's important for us to get that data from you so we can know how to best manage that device long-term. Vegetative best management practices typically include plant establishment periods and followed by maintenance periods as well. And again, that was discussed in the erosion control, but in a lot of these areas, we're trying to establish native plant populations where there used to be only invasives or bare dirt. And so that plant establishment period is critical. And we rely on the contractors to help give those plants a good start. So some of the typical post-construction BMPs that DOT Highways has installed, let me go through those. And this is kind of a good exercise. This is an erosion repair project. And here we have both a combination of temporary and permanent BMPs. And if you look on the slope here, this erosion control fabric is part of the permanent BMP project. And you can also see little holes that are cut out for them to plant the native grasses. They're like grass plugs that'll be installed at those sites. And at the base of the slope here, we have hydromulch that has a native seed mix. And that's also going to be part of the permanent BMP. But this fiber roll at the base of the slope is a temporary BMP. So that's something you need to be aware of on the design plans and in your stormwater pollution prevention plan, that if you want to take credit for these permanent BMP, the fabric and the hydromulch as part of your construction BMP, that needs to be included in your SWIP, as well as this fiber roll. Here's just another view with, you've got the erosion matting, the temp BMP, or the fiber mulch, and then the temp BMP fiber roll. And then once the plants have established and the grasses have grown at the base of the slope, you can see the temp BMP has been removed. Another type of erosion repair, sometimes when we're working underneath an overpass or a really steep area where we have poor soils, here we don't, the vegetation would have a difficult time establishing due to low light and wouldn't get a lot of rainfall. So we do something like grouted riprap. And here you can see as they're putting in the grouted riprap with all these drains in place to make sure that the slope can drain without having any structural issues. And then another type of post-construction BMP that we use frequently, and it's probably one of our most frequently used low impact development type of BMP, is grass swale or a bioswale. So a grass swale is just a vegetated drainage channel or stormwater depression for surface stormwater runoff. And then the bioswale is similar to vegetated swale, and it looks similar at the surface, but it also has a layer of engineered soils and that provide biofiltration. And I'll show you a little bit more about that in a moment, the cross section. So this surface layer, if it's just a grass swale, typically will only have the surface area that will drain to another drainage structure. But the bioswale also has this typically an underdrain system. So we'll have an aggregate storage layer at the bottom. And this is so that as water filters through, there's some initial storage for when a storm initially happens. And then the ideal scenario is that all that stormwater infiltrates into the ground. And that's more of a natural, the natural way the hydrology would work. If there isn't good infiltration, or if the storm is too large to allow for much infiltration, then the water will build up and make it into the underdrain system, and then this will drain to the MS4. This engineered soils layer is very critical. As a contractor, you're going to be provided specifications, and this soil layer is specifically engineered for the types of plants we're going to be planting and the types of nutrients that nutrients or pollutants that we're trying to filter out. And then, of course, the surface mulch layer and plantings complete the top of the bioswale. Here are some examples of a bioswale on H3 in Kaneohe. This was prior to bioswale construction. You can see the existing channel was a concrete channel. So in this scenario, the water runs quickly off the roadway, runs quickly down the concrete channel and straight into the storm drain without any sort of treatment, and also creates a larger flow event into the system than would naturally occur. So there were 26 locations where these concrete channels were removed. And you can see they're digging the bioswale. And in this particular case, they lined the bioswale. Only the sides of the bioswale were lined with a plastic sheeting. And then the bottom was left open for infiltration. And so here you can see them placing the aggregate storage layer. And the next layer would be the engineered soils. So this is a sample specification, but so it's important to us that the spec be followed, and as a contractor, you'll be asked to submit a sample and a specification sheet from wherever you're getting this, wherever the source of your engineered soils are. And it's important to also to note that once, during construction, it's really important to protect these, the aggregate layer. We've had instances where during construction, there's a large rain event and fine sediments made it down into the aggregate layer, which really decreases the capacity for storage long-term for these bioswales. And as you can see here, this is after the engineered soils have been installed, and then this is a biodegradable matting with the hydromulch on the surface. So now, instead of the water going directly off the paved surface into a paved concrete channel, it flows into this swale and is slowed by the surface grasses. Hopefully we get a good amount of infiltration into the aggregate layer and ultimately into the soil. And then whatever does make it into the storm drain has at least been filtered by the surface swale or the underdrain system. Okay, some of the other types of post-construction BMPs we have. This is a downspout filter box. So you'll notice that the DOT highways on Oahu has a lot of sections of freeway that are elevated on viaducts. And those viaducts still collect stormwater, and that stormwater has to go somewhere. And most of the stormwater goes into deck drains that ultimately go into these downspouts and discharge below the freeway. Historically, a lot of those were designed to just discharge directly into streams or directly into a different inlet below the viaduct and then straight out of the system. So what we've been doing is going through and putting in filter boxes, and that this filter boxes, as you can see, collect sediment, trash. They do have an overflow to allow for stormwater overflow during high flow events, because it's also important that we do not cause flooding on the freeways. Another permanent BMP that we've been using is the automatic retractable screen guards. And these are more geared toward helping DOT highways meet their trash reduction plan requirement. They actually have a triggering mechanism. So during high flows, the locking mechanism will release and let the flows through so we don't get flooding. But during sweeping events, they stay locked. And so the way these are maintained typically is by a sweeper truck. And the sweeper truck can go right up against the screen and suck up anything that got trapped. We're shooting for trash. We do get a lot of organics and other debris. And one of the issues that we have noticed, I'll zoom ahead here, is when we do get these organics and litter built up, then it often will hinder the automatic unlocking mechanism from working properly. So as contractors, during your maintenance period, we're looking for you to give us information on how frequently different screen guards in different areas need to be cleaned in order to keep them operational and functioning properly. Another type of device that we use is a graded inlet skimmer box or graded inlet filter. So this is just a simple device that is installed, usually custom sized for whichever inlets we're trying to target. And then they have these oil grease booms, and the basket just basically drops right in below the graded inlet. And there's an example of one in the ground. You can see looking down through the edge of the grate there. And similar with other devices, we're going to have our contractors maintain these for 9 to 12 months. And typically it's on a monthly schedule so that we can get an idea of what our maintenance requirements on these will look like long term. So a larger scale type of device, and this would definitely be considered a permanent BMP and not a low impact development type of device. But due to the nature of the property, the DOT highways owns, which is usually narrow strips of corridor, and they have limited right of way to build and construct permanent BMPs. It's often these types of devices that can treat a large amount of stormwater in a small area are the only device possible to meet different requirements. So a hydrodynamic separator, basically, these things can be sized to meet to match whatever your drainage runoff area is requirements are, but they have several different actions. As water flows in, they're actually designed during flow events to create a swirling action, and the swirling action causes the fine sediments the fine sediments basically go into the middle of the whirlpool, and then they settle out into the settling chamber down here at the bottom. And floatables get trapped underneath this baffle system, and those can be cleaned by just popping the lid and skimming the floatables off the top. The more difficult task is cleaning the sediment out of the sediment chamber down below. And so as a contractor, it's important that you know exactly what the dimensions and depth of the device is, and that when you're cleaning, you get all the way down to the sediment chamber. We have had instances where as you can see, there's a little bit of a shelf here where only this top chamber gets cleaned, and then we go back to take a measurement and realize this lower sediment chamber hasn't actually been cleaned. So it's important to understand how to measure these devices. Another type of large-scale device that we use is a nutrient separating baffle box and or a water polisher. Sometimes we have a combination of devices, of these two devices. But basically, this is a large vault that is put in usually toward the end of a long run of inlets. And this has the advantage of treating a lot of stormwater in one location. It's a lot more expensive upfront construction, but longer term, it only needs to be maintained once or twice a year. So over time, you make up for construction costs by having lower maintenance costs. And so this one's pretty interesting. It's got a basket that collects floatables, and then it's got a series of chambers and baffles, and the baffles basically create a swirling action so that the most coarse sediments settle out in the first chamber, but as the water and sediments make their way through the baffle systems, the second and third chamber settle out finer and finer sediment. And we definitely notice this when we do our cleanings, that we get a lot of gravel and coarse sediments in the first chamber, and by the time we get to the third chamber, it's a lot of sludge and really fine sediments. And then the other component of this device is that it has a oil boom system to collect floating greases and oils. The other component of this, it's called a water polisher. And in areas where we have more dissolved nutrients or really fine sediments that we're concerned about, we sometimes tack this water polisher on to the end of this baffle box. And this, in addition to the baffle systems, the water has to pass under and through this upflow media filter. So the advantage of this design is that it doesn't need it. It needs basically no grade drop. So a lot of times the area that we're discharging from off the side of the highway and then into the storm system, we don't have any sort of gradient drop. And so those, like the CDS units require some sort of grade drop to allow the stormwater to gain some velocity. Whereas this one works well where you have a flat grade. And it's also self-cleaning. So as the water is forced up through the media filter and the flow event stops, the water actually settles back through the media filter, and then the fine sediments settle into this third chamber. So here's just a few photos of a nutrient separating baffle box being constructed in Kaneohe. You can see there's a large, I think this was a 54-inch pipe at the end of a long run of catch basins just prior to discharge into Kaneohe stream. And they cut out the pipe section for the baffle box. And here's a different angle where you can see them setting the concrete vault for the baffle box. So now all the water that used to just flow directly through this pipe into the stream is treated through this baffle box system. Here's that area where we have a water polisher. Sometimes we rely, we really appreciate feedback during construction from the contractor. We can't anticipate every scenario when we're designing. So in this particular case, there was, after the contractor had installed this vault, this was out in Waianae at one of DOT's base yards, they put in an RFI asking about what they should do about the cats. And we were a little bit perplexed at first, but realized that they were using, the cats had found this a good place to sleep. So that's something we hadn't designed for, but there was a simple solution, and we basically just put this little screen on there to keep the cats out for their safety and also to keep the water clean. And then here's just another view of one of the water polishers. We've tried on our more recent designs to use these access hatches rather than manholes in areas that are located behind guardrails, so for easier maintenance. But again, the contractor, we're going to ask you to be responsible for this maintenance for the first 9 to 12 months. And that's going to require, for the baffle boxes and water polishers in particular, for you to have a vac truck. So here's a vac truck being used to clean this water polisher baffle box combo. And if you look down in there, you can see this is one of those upflow media filters. The other key is that you have all your filters available and on site during the cleaning. These filters need to be cleaned once the water is actually drained out of the baffle box. And we've had a few instances where contractor shows up, starts draining the baffle box, but didn't bring the filter replacement. So it causes a whole second cleaning to be required to come out and drain the box again and put the filters in. And along in the design specs, we do make sure to include the manufacturer's specifications and the requirements for which filters are required and all that kind of stuff. And so here's just before and after the cleaning. And this is just an example of some of the information we're going to be asking you for when you're doing your cleaning. Mostly we just want to know sediment accumulation, and you can give that to us in weight or volume. We want to know somewhat the composition of the, how much is organics, how much is trash. And we typically will have one of our inspectors accompany also in case you have any other questions or concerns when you're doing maintenance. And that is all I have.
Thank you for that informative presentation, John. We're now going to open up for the question and answer portion of the session. If anyone has any questions for John, please type them in the Q&A section at this time.
All right, we must have done really well.
You must have answered everybody's question. I think S. Watanabe wanted to say, good to know they're using some of those devices. So So it's very helpful. Oh, John, could you stop screen or sharing your screen?
Yes.
Thank you. Wonderful. While we're waiting, is there any other tips or anything you'd like to add, John?
Not really. I guess. Well, I'm getting some feedback. I think it's from you, maybe. I think a big one is, just reinforcing that the difference between construction and post-construction BMPs. And I know sometimes there's some confusion, especially with our erosion control projects, on when the design plans themselves call for stabilization of a slope through permanent matting. If you're going to take credit for that on your temporary construction BMPs, then that actually needs to be included on your SWIP as well. And I'm sure many of you have worked with Claudia, and she can help you to determine, when it's appropriate to call those to call those temporary BMPs permanent BMPs and vice versa.
Wonderful, thank you. So we do have some questions rolling in. So the first one is from Audrey, and she says, do you have any advice for designers about adding features to these structures to make access and sampling easier?
That's a good question. Yeah, we have. We've had a few sites, especially at our base yards, where in the past we've been required to do a lot of water quality sampling, and so some of our more recent Baffle box and water polisher designs have included built-in monitoring stations, and basically, some areas we've had issues with theft or getting samples collected during the middle of the night and all that kind of stuff. So. Or just getting good sensor placement in a location where we can collect a decent water quality sample. So that is definitely something we've looked at and implemented, is designing the sampling equipment and sampling ports right into the samplers. And then the other example I showed earlier with access hatches being used whenever possible rather than the manholes.
Sounds good, thank you. And then Vijaya Tumala would like to know, do the contractors provide information from the extended maintenance period for permanent BMPs that help you define the frequency of O&M for the various types of BMPs?
Yes, that's definitely one of the benefits of having the contractor maintain the device for a period after they install it. And we typically set the frequency during the contractor's maintenance period at a higher frequency than we plan to long term, but that gives us information on seasonal and monthly variations as well. So that's why it's important to us that the contractors keep up with their maintenance and provide us the data on a monthly basis.
And then we have one more from Marvin C. Was the box pre-casted or cast in place? And then he also adds, if cast in place, then have they ever had a problem with heavy flooding during the construction of the box with the soils and pipes that were exposed? And it says any BMPs that could have been used to protect the area during construction, say if there was a flooding condition, in order to prevent silt and water from flowing to the stream.
Yeah, that's a good question. The boxes are precast, and so basically it's just a matter of preparing the base for the box. But in that photo I showed of the one site, you could see there was they actually did encounter quite a bit of groundwater. So one BMP they had to use was dewatering, obviously, and then they had to come up with a dewatering plan. And definitely, it's a concern when you have an excavation that's that large, that's open, and you're trying to prepare a nice solid base to set that large precast box, that you don't get water flowing into that trench. So you would want, if you were expecting rain, I mean, I guess my first, as hard as difficult as it is to predict, my first approach would be try to do that excavation and setting of the box during a window when you're not expecting much rain. And then you would need some sort of barrier that would completely divert and keep water from flowing into the trench while it's open. Just trying to read, see if there's anything else in the question that I missed. Yeah, so that's about it. But that definitely can be a difficult situation, especially when it's a larger box that you're excavating for.
Okay, and then I guess I'll give just one more minute, see if anybody else has any other questions.
Oh, I've got one in chat here.
Let me pull that up real quick.
Would it be better to design the underdrain at the subgrade instead of mid-depth of the aggregate? So I think what they're saying, I don't know if they mean by the, we basically install it at the top of the aggregate layer because we want water to be able to fill up and store in that aggregate layer and potentially infiltrate. I'm not sure if that's an answer in their question, but that's the purpose for the location of the underdrain. We want it below the engineered soils and above the aggregate storage layer. So the idea is, even though that the pipe is going through the center of the trench, water actually filters through the engineered soils and past the pipe into the aggregate layer, and then as the holes in the pipe are actually pointing down, so as the water fills up the aggregate layer in the trench, that's how it makes it into the underdrain pipe.
And then I think they may have added an extra sentence at the end where they said just thought it would be better sitting on a more impervious material.
Yeah, in this case, we actually want it sitting on a pervious material. It's sitting on, like I said, basically on top of the aggregate layer with the holes pointing down, and that's to keep sediment from getting inside the holes and clogging them up. And so the water actually, it's kind of counterintuitive, but the water actually enters that underdrain from underneath. So hopefully that answers the question.
I think that looks like that's all the questions that have popped up. So let me transition here. 1 second. All right, well, thank you so much, John, for your presentation. This now concludes this session. Thank you for attending. And the next session will begin at 2 p.m. Please return to the sessions tab to see the next breakout sessions. Don't forget to stop by the networking lounge to talk with other attendees and check the leaderboard to see if you are in the lead. We do have a Yeti cooler up for grabs. There's still a lot of time to earn points. Thank you.
Thank you.
Thanks, bye.